Hi everyone, Quiveen here from the comfort of my kitchen. In today's video, we are going to continue looking into the future, inspired by last week's video where we looked at the transit of Mercury coming up in 2032 and the return of Halley's Comet in 2061. We are going to look even further into the future, even further than 2061, to see the very next transit of Venus that will be visible from the Earth. But before we do, we're going to travel back in time, and not quite as far back in time, to see the last transit of Venus that was visible from the Earth. You can see here that we're positioning ourselves in the Pacific Ocean, just under this peninsula here and across from this island here, roughly here in the Pacific Ocean, around the top of Micronesia, a little bit over from Hawaii, which would be, I believe, there. This is pretty much where the eclipse looked its best, way back in 2012. So let's get the sun up into the sky first and foremost. Of course, we only get to see transits during the day. And let's move ourselves back in time just over a decade, 12 years from 2024 to 2012. And we're going to move up into the summer just about here. Now, looking at the sun, nothing really looks different. If I remove the atmosphere, we will get to see it's a little bit tough, but there is Venus right in front of the sun. So let's take a closer look here so that we can see the little dot of Venus. And although it is only a small dot in comparison to the sun, there we go, it is still significantly larger than the dot we saw for Mercury. Mercury, of course, is a much smaller planet, but it is also further from us and closer to the sun when we're on the same side of the sun. Venus is bigger than Mercury and closer to us. So both of those factors contribute to how large the disk of Venus looks as it crosses the sun. Of course, Venus is a teeny tiny fraction of the sun's size, much smaller than it appears here, but it is closer to us, so it looks larger than the further away sun. These transits take hours. Venus orbits the sun much more slowly than Mercury. So there we go, finishing up at about 2:30. This transit started at about 8:30 in the morning. The planet Venus here isn't transiting across the equator of the sun. It is still making a chord across the disk of the sun, pretty close to one pole, I believe the South Pole. Of course, it's really hard to tell in space when you don't have any frame of reference what's north and what's south. But here we go, the start of the transit, yeah, just there at about 8:30. So this transit lasts longer and will last longer than a transit of Mercury that's making the same kind of chord across the surface of the sun. But of course, even with Mercury's quicker orbit of the sun compared to Venus, if Mercury is going across the equator and Venus is going across just the edge of the sun, of course Venus will have a shorter distance that it needs to cross in order to complete its transit. So generally a transit of Venus will last longer than a transit of Mercury, but other factors do need to be considered. Because we're observing this pretty close to the equator, we have that weird flipping of the sun as we move through the day and as we move past midday. The reason I selected this location for observing the transit, even though it was visible from a reasonable portion of the Earth's surface, we can see just about here, pretty much at midday, Venus is pretty much on that north-south axis of the sun. So the middle of the eclipse happened, or the middle of the transit happened roughly in the middle of the day. And that's really the ideal condition you want. It'll give you the longest time possible to observe the transit. And observing transits like this, they give us a little bit of practice when it comes to observing transiting exoplanets. By looking at Venus moving in front of the sun while the sun was active, with plenty of sunspots and plenty of these ejections and flares around the side, it gave scientists a little bit of practice looking at planets, in this case Venus, in front of stars that are a little bit more erratic or active, with a bit more stuff going on. Our sun goes through an 11-year cycle where it goes from a lot of activity to much, much less activity. We'll see a lot of sunspots when it's at its active peak and far fewer sunspots when it is not. So that gives us an opportunity to compare what a planet looks like when it's moving in front of a star that is very active compared to a star that is less active. Unfortunately, the eclipses of Venus are far less regular than, or the transits of Venus are far less regular than transits of Mercury. So we are looking here all the way forward to 2117, the year 2117. I am very hopeful that I will be around until 2061 to observe the return of Halley's Comet. To 2117, I am not quite as confident. But then again, there are always advances in medical technology. Who knows? I might survive to this far future transit, which, as it happens, will be visible in pretty ideal conditions from roughly the same location. We can see Venus here transiting the sun hundreds, well, 100, slightly less than 100 years into the future. We can see Venus transiting the sun here from the same location. We're still looking at this occurring from roughly the Pacific. We can see that the transit is still taking a nice long period of time. This would be the start of the transit, just 10:15. We'll see that the transit reaches its peak, I believe, a little bit after midday. So this eclipse might be better viewed from slightly further over in the Pacific Ocean. It might look a little bit better from the main island of Hawaii than from Micronesia. But of course, these eclipses these transits aren't going to be visible in the same place all of the time. This is a transit really because the object we're looking at isn't completely blocking the sun. The difference between a transit and an eclipse, it's usually down to how much of the sun is obscured. Our moon can block out the sun's disk almost entirely, whereas the planet Venus, despite being much larger than our moon, it's not quite big enough to obscure enough of the sun. These kinds of events usually do require specialized equipment to observe, solar telescopes that are designed for looking at the sun. That would be even more important with Mercury, given that it presents such a small dot. Whereas if you're taking a look at Venus with eclipse glasses or welder's glass to protect your eyes, you might be able to see a little black dot with your naked eye. I can't confirm that. I didn't get to see the eclipse of Venus or the transit of Venus in 2012. And as I said, I'm not so confident that I will be here to see the eclipse of Venus in 2117. And even if I am, I will have to book tickets to Wake Island or some other part of Micronesia in order to be able to see it at all. We get eclipses here on Earth, and I've mentioned in the past that not every planet in the universe, not every planet in the galaxy, and certainly not every planet in the solar system gets to see eclipses the way we do. On Mars, eclipses are way more frequent. Given that Mars has very small moons orbiting quite close to the planet and orbiting quite quickly, they pass in front of the sun more often than our moon does. But they don't really cause eclipses. They do cause transits. So that is what we're going to look at here, and we are going to travel back in time to 2004. As I mentioned, the eclipses on Mars are much more frequent than the eclipses here on Earth. But of course, people haven't put as much time into calculating exactly when they occur because nobody's there to see them, or at least no people are there to see them. Luckily, in 2004, March, I hope I'm after getting these dates right, we are on Mars, of course, the Opportunity rover got to see a transit of the moon Phobos passing in front of the sun from Mars. Now, I may have gotten my dates wrong here, but let's see what we can do. Because these moons orbit incredibly quickly. So there we go. That is, I believe, passing just barely over the sun. I may have gotten my dates wrong a little bit, but let's take a look. Let's see if we're getting any occultation or zygzaggy, a lining up of these objects. Nope, not quite. That's okay. I am not too far off. So let's see if I can get through a couple of days here. Oh, maybe. It does happen very quickly. As I say, these moons orbit very fast. They are orbiting lower in Mars's orbit. Here we go. I don't want to move things too quickly or I'll miss it. It's not quite something that happens in the blink of an eye, but it is much quicker than the eclipses here on Earth. So here comes Phobos. moving back in time, and any second now, there we go. And we can see that even though Phobos, it's close enough to Mars that despite its very small size, it causes something comparable to an annular eclipse here on Earth, but not quite as much coverage as an annular eclipse would give our sun. So here we go. We can clearly see a large portion of the sun around the moon Phobos. On Mars, the atmosphere has a very different composition, so it wouldn't look like this. It wouldn't be a lovely blue sky. But we can see that the moon Phobos doesn't quite block out enough of the sun to cause something that would be comparable to an eclipse here on Earth. This is an eclipse that was witnessed by a rover on Mars. The Opportunity rover was able to observe this transit, not really an eclipse, but this transit was observed by a robot on Mars. So these kinds of phenomenon, moons moving in front of the star, that has been observed and does occur for other objects in space, but it's not exactly comparable to the kind of eclipse that we would have here on Earth. Definitely still a much larger portion of the sun being blocked out than it would be in a transit of Venus. So that is a quick look into the past, into the future, and back into the past from a different world, just to look at some things moving in front of the sun to round off our discussion of transits with the transit of Mercury, again coming up in 2032. So that is something we will get a chance to see from here on Earth in just a few years' time. I hope that you get to see the transit of Mercury. Hopefully some of you will outlive me until 2117 to see the next transit of Venus, although we've more, hopefully, medical technology might be able to extend my life that far. It would be nice to see a transit of Venus. They are, as I say, very, very rare. Observing this kind of transit of a moon on Mars, even if technology brings us to the point where I could visit Mars and observe this, I will definitely let some other people make that journey first, just to make sure that it is safe. Of course, none of you, my viewers, need to travel to Mars to see these kinds of things, because I will show you. And if you'd like to see more of them, make sure to subscribe to this YouTube channel. And if you enjoyed this look at these rare events, or not so rare in the case of this Phobos transiting the sun, then do make sure to like the video. And if you'd like to read some of this information, you can check it out on my website, queevienscontent.ie. But until next time.